Welcome to Efiwe, excellence without stress.
Welcome guys to Efiwe, excellence without stress. And in today's study we are going to be considering nuclear chemistry. Now, let's get into the study. Radioactivity is simply defined as the spontaneous emission of radiation by an element. Such an element is called a radioactive element. A radioactive substance emits radiation continually and spontaneously. Unlike light rays, they can actually penetrate through opaque matter. You know, light doesn't actually pass through opaque matter. But once you are talking about a radioactive radiation, it has the ability to penetrate through opaque matter. The type of energy from radioactivity is called nuclear energy. So once you're talking about nuclear energy or nuclear chemistry, you're looking at the form of chemistry that is associated with radioactive processes. So, moving ahead. What are the types of radiations? We have radioactive radiations, which include the alpha particle, the beta particle, and the gamma particle. Let's look into them briefly. So, with this said, the alpha particles are the positively charged particles. Alpha particle is highly active and energetic. It actually has the helium atom structure. That is to say that it contains 2 neutrons and 2 protons. So if I am to represent an alpha particle, it would have the atomic mass of 4 and atomic number of 2. So always take note of that. This is the symbol, but the atomic mass is 4 and the atomic number is 2. These particles have minimum penetration power and they have the highest ionization energy. So take note, penetration power is the lowest for alpha particles. However, their ionization energy is the highest. They can cause serious damage if they get into the body due to their high ionization power. They are capable of ionizing numerous atoms by a short distance. So the point is this, that they have high ionization power but low penetrating power, which means they cannot pass through thick lead bodies or obstructors. You get, so basically that remember, they have the helium structure, meaning that they have atomic mass of 4 and atomic number of 2. Moving ahead, the beta particles, on the other hand, are extremely energetic electrons that are liberated from the inner nucleus. They bear a negligible mass. That is exactly why the atomic mass, as you can see, is 0 in this case. However, they are negatively charged. A neutron in the nucleus splits into a proton and an electron on the emission of a beta particle. So just take note of that is basically how a beta particle is formed. Hence, it is the electron that is emitted by the nucleus at a rapid pace. So these particular beta particles are basically electrons. Just have that in mind. Beta particles have higher penetration power when compared to alpha particles and can travel through skin with ease. So have that in mind. Gamma rays, on the other hand, are basically waves arising from high frequency end of electromagnetic spectrum that has no mass and are known as gamma rays. So when you consider the mass of gamma rays, there are no masses, neither does it have a charge. They hold the highest power of penetration. So between alpha, beta, and gamma, the lowest penetration is alpha, the highest penetration is gamma. They are the most penetrating but least ionizing, and very difficult to resist them from entering the body. The gamma rays carry a large amount of energy and can also travel via thick concrete and thin lead. So that's that basically. The gamma rays can actually penetrate through concrete and then thin lead. The next thing we are going to discuss are the properties of alpha, beta, and gamma rays. So what are they? Alpha rays are helium particles, beta rays are electrons, while gamma rays are electromagnetic waves. The charges: alpha ray is positively charged, beta ray is negatively charged, while gamma ray is neutral. Ionizing power: alpha rays has 100 times greater ionizing power than beta rays and 10,000 times greater than gamma rays. Comparatively low for your beta, and then the very lowest ionization power is possessed by gamma rays amongst the 3. The penetrating power of alpha is the lowest, followed by that of beta, and then the highest penetrating power is possessed by gamma rays. The effects of electric and magnetic field: alpha rays are deflected by both fields, that is both electric field and magnetic field, beta rays are also deflected by both of them, while in the case of gamma rays, they are neither deflected by electric field nor your magnetic field because it's neutral. Then finally, the speed. Their speed ranges from 1/10 to 1/20 times the speed of light. That's that. Their speed can go up to 9/10 times the speed of light, and then they travel with the speed of light, which means the fastest is gamma ray while the slowest is alpha rays. We go into the next one, which is natural radioactivity and artificial radioactivity. Now, when you say that reactivity is natural, it basically simply means that the radioactive element undergoes radioactive decay without external force. So, when a radioactive element undergoes radioactive decay, it may emit either a particle or particles of gamma rays. This changes the atomic number of the element, hence a new element is formed. So, you have that, for example, radium-226 decays by emitting alpha particle to turn into a new element, radon. We can actually depict that. Radium has a mass number of 226, an atomic number of 88. Hence, it is denoted by Ra. On the other hand, you will notice that the radon that is produced will have an atomic mass of 222 and the atomic number of 86. We can actually express that on our writing board. So to express this, we'll have that radium, which has 226 as atomic mass and 88 as atomic number, would actually give off helium particles to produce radon. The helium particle or alpha particle has 4 and 2, and then also give off energy. Now imagine we do not know the values of the atomic masses. How do we get this? Equate every value here to every value here. So that means 226 would be equals x plus 4, which means that x is going to be 226 minus 4. And when you do that, the value for the atomic mass of radon will now be 222. In the case of its atomic number, we can do the same thing. 88 equals y plus 2. So the implication is that y is going to be equals 88 minus 2. And if you do that, your value is going to become 86. Hence, if we are looking for the atomic mass of radon, it's going to be given as 222, while the atomic number is given as 86. I presume this was helpful to your understanding of the concept. Now, moving ahead. The next thing we are going to talk about is artificial radioactivity. If radioactivity is induced in an element by irradiation with, for example, neutrons, the process is known as artificial radioactivity. So when it is man that induces the radioactive process, that is when it is referred to as artificial radioactivity. By irradiation, we mean exposure to radiation, either by accident or by intent. So take, for instance, you have this reaction here, where helium or alpha particles tend to bombard your nitrogen particles. You find out that in this reaction, it will lead to the production of fluorine, which is a different element. And when fluorine decides to give off a proton, it now leads to the production of oxygen. And that's that basically about your artificial radioactivity. Applications of radioactivity. Radioactivity can be applied in agriculture and in scientific research. Radioactive elements are used in agriculture as radioactive tracers and to induce mutation in plants and animals to obtain new and improved varieties. Geologists and archaeologists may use this for measurement of half-life to estimate the age of rocks, and carbon dating can actually be used to find the date of organic remains. This is referred to as radioactive dating. Medical field. Gamma rays from radioactive substances are used to treat cancer patients, to sterilize surgical equipment, foods, etc. In industry, radioactive elements are used in the industry to study defects in metals and welded joints, and also to check metal fatigue. As a radioactive isotope, they can be used to trace underground pipe leakages. And these are your applications of radioactivity. I presume you have learned a lot. Don't forget to solve the questions in the Efiwe app. Thank you very much.